Hi, thanks for joining me. Just a quick video from me today. Today I'm going to be sharing with you a problem or an adapted problem from the 2011 maths exam. This is the exam you have to do if you want to study maths at the University of Oxford. Link in the description below where you can find more information about the math. Anyway, this is the problem. Suppose we have a rectangle with perimeter P and area A. We want to prove this inequality here holds true. P squared is bigger than or equal to 16a. Okay, so if you want to have a go at this problem, pause the video now and give it a go for yourself. And I'm going to jump straight into a solution. Okay, so let's take a generic rectangle and label the side lengths alpha and beta. And let's firstly build some relationships between P and A and alpha and beta. So the perimeter of this rectangle is just alpha plus beta, which of course is just 2 times alpha plus beta. So P equals 2 alpha plus beta. Now the area A is just alpha times beta, so alpha beta. Now remember what we're trying to do is prove that P squared is at least 16a, so we've got to build a relationship between P and A, and the way we're going to do that is by comparing these two equations by isolating one of alpha or beta, and if we just look, they're sort of symmetric, so it doesn't matter which one we choose, so we're going to choose alpha. So alpha equals, now if we isolate alpha in the first equation, we get that alpha is equal to P over 2 minus beta, like so. But if we isolate alpha in the second equation, we get that alpha is A over beta, like so. So now we've got an equation involving P, beta and A, and we've kind of eliminated alpha. So now if we just look at this equation here and multiply through by beta, we get that P over 2 beta minus beta squared equals A. And just bringing everything onto one side, so bringing everything to this right hand side, we get the beta squared minus P over 2 beta plus A equals 0. So now if we have a look at this, hopefully you can see that this is a quadratic in beta. But what do we know about beta? Well, it's the side length of a rectangle, so somewhat subtly we know that it's a positive real number. And it being positive is not important to this part here, but it's actually the fact that it's a real number, which is important. The fact that it's a real number tells us that, and it's the fact that it's a solution to this quadratic here, tells us that the discriminant of this quadratic here must be non-negative, because if it were negative, that would insinuate that beta is a complex number, or not a real number. So, and obviously that wouldn't make any sense. So we must have that the discriminant of this guy is non-negative, so strictly bigger than or equal to 0. So if we look at the discriminant of this guy here, we get P over 2 squared minus 4 times 1 times A being bigger than or equal to 0. Because remember, of course, you take this coefficient of the second term, square that, and then subtract off 4 times the coefficient of the first times the last, and you get this guy here, which is bigger than or equal to 0. Then if you just multiply through by 4, you get the inequality you want. P squared minus 16a is bigger than or equal to 0, and then of course you can just add 16a to both sides. Anyway, that's how you solve this fun math problem. If you want to see more sort of Oxford/Cambridge maths related content, I'll leave a link to a playlist I have where I've put together a bunch of videos. So that includes map solution videos, step solution videos, and also a couple of videos of me talking about what it's like to do maths at Oxford. Anyway, thank you for watching. I'll catch you in the next one. Have a great day.